We're going to go. So let's get going. And I want to start with the AI news of the day. And this is interesting because we'll talk about this a little bit more at the end of the very last class. One thing you should know about that we're not going to go into much detail is brain-computer interfaces, or BCI. And BCI interfaces are being popularized by things like Neuralink, that company that Elon Musk has. But there's a lot of very serious work going on in the field, some of which is actually going on at UCSF, just up here. And so I want to tell you two things about this that I never thought I would actually see. One of the pieces of evidence that people have been working on is to basically have implants, so real wires in your brain, in visual cortex, which is back here, back of your brain, and they can actually then reconstruct what you're seeing just from your neural patterns. And so what you should see in this top row are the original stimulus images, and the bottom row is the reconstructed images. I don't know how they do this, but this particular piece of work is being done by the University of Netherlands. And this is actually in macaques. We don't put that many neural implants into people just yet, but this is pretty remarkable stuff. Closer to home, this is a brain implant that's being used in a clinical setting. So in particular, people who have inability to speak can get an implant like this, which allows them to speak and actually control devices with their inner voice. And of course, you can then take that and connect it to a voice model which has been trained on your own voice. Interesting thing, because as you know, you can take a fairly small number of samples and recreate a speech model which is very much like you. Okay, this for people who have locked-in syndrome or whatever is truly phenomenal. This is an interesting advance of AI work. I want you, however, to think about this. What happens when the company who made this implant goes bankrupt? This is not a hypothetical question. A few years ago, there was a company that built a retinal implant. That is, it actually would stick into your back of your eye and then connect to your visual cortex back here, and gave people who were blind, clinically blind, stone cold, they saw nothing, the ability to see. Pretty phenomenal, right? Amazing work. People had this implant for 5 years. The company went bankrupt, and the company wanted their implants back. Okay, see any problem with this? Several of the patients said, no, I'm sorry, I'm not having surgery to reverse this thing. I'll just keep it up. And they kept their device until one day when a software push broke everything. And they went blind again, which is a reversion to the previous state. So in some sense, you can sort of understand that. But those people now have a big piece of metal in their head, and they had to get an MRI. Sorry, can't do it. MRI is required that there be no metal in your body. Okay, so they are now locked out of getting CAT scans and MRIs of their head. So it's a huge problem. These people have the same problem. So the reason I'm telling you this is partly because it's an interesting AI application. Equally important, we need to think about the future consequences of technology as we develop it, not just for the immediate function of the thing, but also for its end of life. How do you stop using ChatGPT? What happens if, say, OpenAI goes bankrupt? What happens if Google goes away? Right? We need to think about those as well. And just for fun, and because it's a very hot topic right this week, this week in Zurich, at the film festival there, what's her name? Tilly Norwood was introduced to the world as a fully synthetic AI synthespian. So she's not a real person. She's purely an AI model, which can be animated. You've used these things. You've seen them before. But the proposal has been now to put her into movies and let her do interviews the whole 9 yards. see where this is going. And you can see the response on the left-hand side. The Screen Actors Guild, SAG, and all the other professional associations are, of course, horrified by this. Question for you as a consumer: if you can't tell the difference between fake Tilly Norwood and real Tilly Norwood, does it matter to you? Because you've already seen this. Remember Star Wars, there were several characters that had died and they just put them in anyway. They animated their visual presence. So this is becoming more and more what we do. AI can generate increasingly sophisticated representations of people, have them act. And we'll go into more detail on this later, but I thought this was interesting. As of this week, this is the current hot topic in Hollywood. Okay, quick, before we get into today's topic, when you write up your assignments, because I've started looking at all the assignments already, make sure you put your name on there. Yes, I know, I can figure out your name by looking at the metadata for the file, but don't make me go to that trouble. Make your user's life easy. Just put your name. You know how to type your name? Just put it at the top of your document, okay? Second thing, make sure your document is editable. I've already pinged a couple of people, said, please, I need to be able to read it. I need to be able to edit it, to leave comments. These guys too. So just make it editable universally, and I think you'll be fine, okay? So a couple of the comments I've seen on the best of the assignment number 1, so general advice. This assignment should have had data from your users. Remember, from your uses. How did you use AI this week? And so one question I had for multiple people was, did you really only use 2 AI systems this week? I don't believe you. You're embedded in an AI universe, and I think you're probably using more than just ChatGPT. Right? So part of the assignment was to make you aware of all these things. So did anybody this past week, when they did the assignment, have an AI system that they discovered they didn't realize was AI? I was like, what did you find? Face reco, yeah, exactly, on the phone.
When you're like typing on your iPad, it makes the text look better. Like it auto fixes your.
Oh yeah, autocorrect with the pen when you're
like, it doesn't change the font. It doesn't spell correct. It like makes the letters look pretty.
It prettifies the text. Yeah. It's like text cleanup or something like that. Anybody else? No. Okay, those are 2 great examples. Should have been in your data set. And the other thing, I guess the last comment I'll have is that I was looking for an analysis that was a little deeper than, I used a bunch of AI systems. Like, thank you, I know that, right? I wanted to understand, how did they change your work for good or for ill? So they made your text pretty. Awesome, right? You were able to get into your phone quickly because you've got this AI reco thing. Awesome. Importantly, did they change the frame of your kind of work? Okay. So that's okay. So let's actually spend a second talking about assignment number 2, which is I'm handing out today. So it's number 2, and I'm going to give you a couple hints. What I want you to do, be sure to read this whole thing, but I'm going to point out a couple of things. You've been tasked to design a party invitation for a party that would have been held in the 19th century. I love playing historical tricks. There was no AI in the 19th century, but imagine if there was, right? I want your AI system to generate a party invitation as though it came out of the Gilded Age, the Gilded Era in the United States. So you should think, what does that look like? And how will I know what it looks like? How will I know that it did a good job? Okay. So do that. That's thing 1, task 1. So do that. I don't care which one you use. I encourage you to use 2 different AI gen systems just to see what the differences are. When I did it, I found that some would do a great job, some would not do a great job, and the differences between them were interesting. So I want you to try that. When you do that, make a Google slide deck, just a couple slides, done. Just paste them in there, or put them into your Google Doc, paste them in there. Do not submit 2 links. It breaks my code. I just want 1 link, right? So make sure you do that. The second part is to do the same thing, a similar thing, design a party invitation for a space age party using traditional tools. Don't spend a lot of time in this. I want you to do it though to be able to compare and contrast AI design with traditional design practice. So if you spend more than 10 minutes on part 2, you're doing it wrong. Do a very simple, very straightforward thing. And I'm not going to grade you on design. I just wanted you to have the experience of collecting material to be used in the design process and then reflect on the differences. Okay. And then just one page about that. Read that here. All that's good. Okay. There we go. So that's the next assignment, due in a couple of weeks. So it's not a big deal, but I think you'll have a lot of fun with it. I hope so. So here's the plot of the entire course. This is the first 6 weeks. We've done the intro, lecture 1 on Tuesday last week. And we're in the block right now, the yellow block, which is all about mental models and how people think about these things. So today we're really going to focus in on mental models. How do people think about and understand AI systems? Or how do they not think about them? Okay. So let me finish up just a few slides from Tuesday's lecture. Where we had left off was talking about what the fundamental UX design questions are when you're building an AI system. And the one we left off on was this one. What happens when you design an AI system? What happens to the individual user, the community, and society? So you're going to hear this tripartite division, this 3 ways of looking at AI systems over and over again. Individual or the person, the community, and society. So we want to think about that thing we're making in terms of all these different aspects. Okay? So here's one thing. This is a social dimension now. Does using AI systems reduce critical thinking skills? I will spare you the task of reading the next 50 papers. I've read them for you, and it's very up in the air. There are some people who are strongly saying, oh yeah, it absolutely damages critical thinking skills. Other people say, no, it gives us additional amplified thinking skills. I suspect the truth is more in the middle. For a lot of people, it will actually really reduce their critical thinking skills. But here's a study. So this is a paper by these folks. And here's the thing to know about this. I'm going to read this to you because it's important. The key irony of automation is that by mechanizing routine tasks and leaving exception handling to the human user, you deprive the user of the routine opportunities to practice their judgment and strengthen their cognitive musculature, leaving them atrophied and unprepared when exceptions do arise. This should sound really familiar to you. This is the problem of vigilance in a task. And one thing we know about people, we as a species suck at vigilance tasks. We are just not very good at it. The vigilance task comes up when your self-driving car says, hey, I'll take over 99% of the driving. When I call you, you better be vigilant and answer the phone and start driving. We're terrible at that, just terrible. So when we're thinking about critical responses, what happens to you as a person? What happens to us as a society? We have all these dimensions of critical responses to knowledge, to comprehension, to the way you apply it, the way you analyze information, the way you synthesize ideas, and the way you evaluate content. It affects all of that stuff. Key finding, right? Remember a couple of days ago, I said, you have to feel the cognitive friction. You have to feel the burn to know that you're learning. If you're not, right? So these measures of the amount of perceived effort people are doing on these different aspects, the knowledge task, comprehension task, application task, and so on. The distribution of perceived effort is really striking. In a knowledge task, people perceive that they're doing 30% less work than compared with a non-AI augmented task. 30%, that's kind of big. Or comprehension task, it's 39%. Less effort. So the blues are telling you you're skating over the problem. You're just kind of, I'm good. Let's go with it, right? Only 1% or 2% of people said it was actually more work. This looks to me like people are disengaging from critical reasoning when they're doing any of these comprehension, knowledge, application analysis, or synthesis tasks. Here's the other really interesting result I've seen from this paper and other papers. This is a little subtle. Key finding number 2. People who use Gen AI have higher confidence in using the AI system. It's associated with less critical thinking, even though it's perceived as less effort. So if you have high confidence in Gen AI, you have less critical thinking. However, if you have higher self-confidence, it's associated with more critical thinking. Okay? It's an important distinction because it suggests that as people use more and more, they hand off more and more of their cognitive tasks to Gen AI, they stop being as critical. You accept any kind of AI slop. And we in university probably don't want to do that. But contradictory, people have high self-confidence in a domain tend to not accept the Gen AI output blindly. So that's sort of at a personal level. Let's think about the community level thing. So here's an example. I did this query about ancient Roman construction techniques, and I get this AI summary here, talks about construction techniques using concrete, stone, bricks, and so on. And sort of oddly, the last one there, you see it, hypocaust heating. How many people know what a hypocaust is? Anybody? Okay. Classical Greek and Roman architecture. A hypocaust is basically forced air heating underneath the building. It is not a construction technique, right? So that first sentence there is confused. If you wrote that sentence, I would say, what? What do you mean? It's like the categories are all mixed up. Okay, that's one thing. More importantly, multiple companies have said, oh, now that Google has started putting these AI previews as a basis of search results, we're getting fewer click-throughs. Damn. So if you're a company like, say, Chegg, you're seeing that AI overviews have reduced web traffic, and publishers report the same thing. So Penguin, the book company, has seen a 20% drop-off in the click-throughs to their site because people are getting all the information they need from the overview. Historical point. You may not remember this, but in the 14th century, books started to get indices. They started to get an index, right? At what page is this concept measured? Table of contents. Well, how is the book organized? Those an index and a table of contents were introduced late 1400s. People, educators primarily, hated the notion that students would have a table of contents or an index. Why? Because they'll just read the index and they won't read the book. It was exactly the same argument here. Okay? However, we live in a much qualitatively different world than some scribe writing out page 29, the concept of God. Right? That took forever. These are basically instantaneous. And so the time scale is fundamentally different. So what happens to the individual, the community, and society? As you're thinking about designing your new fancy AI startup, please think about this. Think about these 3 levels of analysis. So that's my injunction to you as future AI overlords. Right? Now, let's turn to today's topic, which is mental model stuff. How do people think AI systems work? So we have a lab because we love labs. So we're going to go to quickdraw.withgoogle.com and spend about 5 minutes doing this. And so here's the link. Do this on you can do it on your phone or do it on your laptop, whatever. In some sense, this actually might be better on a phone because you've got direct manipulation. Or if you've got a touch screen, it'd be great. Let's do this and spend a couple minutes. And what I want you to do is to see, as you try to draw these different things, like a bicycle or a piece of cheese or whatever, how much of the drawing do you need to complete before it recognizes what you're doing? Okay, so let's go to quick draw. Like this, quick draw. Okay. Go ahead and just spend a couple of minutes exploring this, and then let's have a conversation. Or if you want to work in teams of two, that'd be great. So here's my first task, draw a toilet. Go for it. I'm going to wander around and look over people's shoulders.
Sorry, I couldn't guess it.
Oh, I got caught that.
Oh, I know. It's rainbow.
Okay, I got it. That was pretty fast.
People succeeding.
Yeah.
They're working.
Okay, this is just a quick one. We're going to do another. We have another lab coming up in just a second. So tell me, how did it work for you guys? Did it work? What was the most fun one you did? Paintbrush. And how many strokes did you do? Yeah, you had to draw the brush, right? Right. Anybody else have a good one? Anybody? Come on, right side, stand up. What are you doing? What was a fun one you guys did? What'd you get? What? A parrot, like the bird? It took quite a while. Okay. Why? Do you have any idea why? Okay. Let's assume you're a talented artist. Yeah. What'd you have?
But it was really, really bad. I don't know how I got it.
But it still figured it out. Yeah, it's pretty amazing, I think. So what this was, the way this works is they took a whole pile of sketches, I forget how many, 75,000 or something, and built the model. And note that you can't draw absolutely anything. It gives you the prompt. So it's asking you to draw something from its training set. So if you drew something really wacky random, like here's an F1 racing car, it's not trained on that, it's not going to get it. This is a fundamental property about classification systems. They are trained on a set of images. Okay, so we have another one here I would want you to try. Autodraw.com. I think, does that still work? I hope it works. Let's go to autodraw.com and do the same kind of thing. But here, you're trying to guess what's in its set. So it's a little bit flipped. So let's do that. We'll spend another 2 minutes on that. Okay. So I'm going to draw something here. Notice that it's giving the guesses in the top bar of the window. And then you can select, delete, draw again. How's it working for people? Can someone try drawing an F1 racing car? See if it guesses it. Okay, has anybody been surprised yet? What surprised you? Yeah. Pumpkin recognition. That's awesome. Or more generally, squash recognition. Did you actually have like little face on it? Like a jack-o'-lantern? Okay. No, it's just a squash. Okay. Suppose you were drawing an apple. How would it be different?
Line through it, but if the line was the wrong direction, so
Okay. Okay. Anybody else surprised by something you drew? Yeah, what'd you get?
I heard these edit and not get
No raccoons. Okay. Ringtail cats, maybe. How about you? Is what? House. Okay. So what we're doing now is the flip of the previous one. We're drawing something and asking it, out of the things you've been trained on, what does this most look like? I'm sorry about the raccoon. It was probably not trained on a raccoon. I wonder if it was trained on skunks. But you see the problem, the mental model problem is you don't know what it can do. And you have no way to figure that out, aside from drawing randomly. So if I was the UX designer for this, what would you do? I would try to communicate somehow, here's the space of things we can do. We can do plants, we can do animals, we can do basic machines. We cannot do cityscapes or recognizable artist reproductions. Okay, so that's auto draw. So let me ask you a different version of this question. We just showed you two sort of sketching interfaces. When can you use these things aside from demos? Here's an example. Google Docs, you may not have known this, but Google Docs has this option where you can insert special characters by drawing the character. It will then recognize the image and go say, oh, that's what you mean. So here, for example, I drew that character. And you see it did exactly the same thing as AutoDraw does. It gives you a set of options up there. So you see right here, the Chinese characters, a lambda is an X. There's a Aramaic character here. You see the point. You can actually start to draw complex characters that you don't even know the name for. Does anybody know what this is called? I have no idea. But you can insert it very quickly by doing that. It's very much greater than. Or if you don't know the keyboard shortcut for Cherokee letters, there's a whole alphabet of Cherokee that I don't know the character equivalents of. But I can do this draw and learn that it's called C and input it that way. And of course, if you think about this in the context of search, you would love to be able to say, hey, let's look over all of the artwork in the Louvre and find things that look like this, like an apple or a pumpkin, right? And so there's a website you can do to do visual searches by sketching. So it recos the sketch and then indexes into the image data set that it's got and gives you the answers. Pretty nice. So here's an example of that being used. So this is a little thing done by Creative Labs. Interesting thing. This was done probably 10 years ago or so. In the late 1990s, and when I was at Apple in the research lab there, we had a version of this. It took 20 years for a prototype to make it into something that people could use every day. So if you're expecting your clever guitar sketch to work, would it find this? You see what I'm getting at? What's the extent to which the recognition will work? How robust is that recognition? Because you will all agree that's a man with a guitar. That's a woman with a guitar. It probably works for both of those. Would it work for that? Maybe. How about that? The title of that piece is Woman with Guitar. Question for you as a user, would you expect that image on the far right side to pop up as a legitimate answer to your query, to your sketch? Because you would sketch a guitar and you think, I want visual things that look like guitars. Oh, here's a Miro piece. Right. I will leave it to you as a designer to think about what the correct answer is there. Right? Now, The other way in which image recognizers could be useful is giving descriptions of images. So here's a nice image. These are 4 little wooden carvings of elephants I happen to have at home. And I took that photo and I asked Gemini, what's in this photo? And it says the image shows 4 black elephant figurines arranged in a line in a wooden surface. Blah. Actually does a very nice job. Beautiful job. You've probably done this. At least one of you in the assignment 1 said that they took a photo of a calendar and then had it recognize what was going on there. We'll talk about this a little bit more later, but this is nice, really beautiful work. However, if I go and search for elephants, I get some really interesting results, including chai, cans of chai, and images of elephants. So asking it to describe these photos doesn't give you anything nearly as good. So here's a deep point. The AI systems of an individual company, Google in this case, you will have different competencies depending on which tool you're using and how you use it. So how do we, as humans, think about our interaction with these things? So we think about search engines. How do we understand what a searcher's mental model is? I want to spend a few minutes talking about this because one way that you do user experience research in a large company is to understand what the mental model is. So these folks over here, you just set up a company, you built this awesome AI thing, right? Great. How does it work? What does it do? How do you portray it to everybody else in your audience? One of the things you can do is to go out and do understanding of what the mental models are. So typically what I've done is and interviewed people, sort of one-on-one, or if you have a small group of people and interview them, how do we understand this thing to work? And I will tell you, in a couple classes, we'll talk about AI tools for doing UX research. And there's a whole movement out there to basically build synthetic users. That is LLM-based user models that will then predict how people will respond. And I'm unconvinced that this will work in anything except basic operations. The most interesting thing about doing interviews with real people is the things you discover that you did never, ever expected. So what we often do is we go out and interview people. We focus on observing people in naturalistic behavior. We try to analyze the things they do. In this case, we're talking about search. What are the common behavior patterns they have? What do they not understand? What goes wrong? How does it go wrong? How do they know? And so a classic ethnographic analysis is that you then create field notes and a, quote, rich description. That's what an ethnographer would say. I'm creating a rich description of how people think about and use these things. So I could teach an entire class on this, which I have done in the past. Huge amounts of fun, but that's all I'm going to give you today. Okay. So why do we do this? Why would we bother going out and talking to real people? I'll tell you, because you will discover things you did not anticipate are not in your model. In particular, I, as a white guy living in Silicon Valley, I've been here for 40 years, have no idea what it's like to be a Hispanic 19-year-old living in the Central Valley. And I can't imagine what they would think about for search or using my fancy AI tool. So you have to go and understand both the way they're using it, the way they're thinking about it, the emotional responses, both positive and negative, and to understand and extract the mental model, the way they're thinking about this. So in the context of search, the mental model determines their behavior, both when things work and when things don't go well. So let me show you a little, this is from a few years ago, but I'm going to show you a few clips from a video that I put together interviewing people about how they use Google search. And I ask everybody, how does Google search work? I'm going to pause it here because I want you to listen not to what she says, not to what she says, but how she says it and how she doesn't say it. This is part of why talking to real people matters. The point isn't that she's dumb. She's an assistant in a university, very smart person, has no mental model for this. And that's really, really common. The irony is that that woman works at Google, not at Google, Yahoo. She works at Yahoo, the other search company back then, and had no idea how anything worked. Okay, so where do our mental models come from? Because there's what's helping us determine what's behaviorally normal and what's behaviorally abnormal. So people have functional models of search. They may not align with the designer's model or what I thought about when I was writing the code. But what do aside from be frustrated? Here's the thing. For a lot of AI systems, people do not have strong functional models. They just don't. They do stuff, they hope for the best. Once they find something that works, they follow in that path forever. And it's very difficult to get them out of that path. So if you don't have a strong causal model, you have very weak predictors, right? People are constantly surprised by these things. And so people need help. So here's a study we did asking people how often they would search for something every day or less than once a day. We found out that basically people were using all these different search engines to ask questions about how to search. So people clearly need help. We did another big study, actually a really big study, trying to get at what kinds of information needs people have. Because I'm going to give you a search engine, right? Here's this AI thing that will answer your questions. What kinds of questions are you going to ask? Your mental model tells you the kinds of things you can ask and the kinds of things you can't ask implicitly. So this is a set of results about people asking another human, sort of the best possible case. What kinds of information needs do they have? So you see things like, will I get in trouble with my food program sponsor if she thinks I was not at home for an inspection? That query has never appeared in Google, right? There's a lot of interesting things that people will say to other human beings that they will never think to ask an LLM or a search engine. On the other hand, I have another slide in another deck that shows that people will disclose medical information like medical histories to an AI system that they would never tell a human being. AI medical history takers are much better than human history takers. And the reason is, you can imagine, people get very comfortable with an AI system and they feel they're presenting information without judgment. What happens if I tell her I've got an STD? I won't disclose that. But people will disclose that to an AI system because they feel it's a judgmental free zone. That's why the affective response matters. Okay. So if, for example, you built a medical history taker, suppose you're the engineer on this, you're the UX designer or the PM, and you build a medical history system that frowns disapprovingly when you reveal your particularly interesting and odd food choices or something. I love to eat earthworms. Browns? All of a sudden, you shut down that open channel. So your affective design matters. So what's interesting is that people, at least once a day, will ask, while they're using Google or whatever, they'll ask for help, or at least express that they don't understand what's going on. What's it doing? Why is it doing this? So now let me tell you what a mental model is technically. I've used the word a lot. In the classic paper by Don Norman, Dietrich Gentner, and Stevens, 1983, there was a definition of a mental model, which is the set of things a user believes about a system. The set of things a user believes to be true about this thing they're using. They have a bunch of facts about it. They know how to make it work. They expect certain things. They know what normal is, what abnormal is, and how to fix things when they get wrong, when they go cattywampus. So if we can talk about, for example, the mental model that my contractor, John, has about the building of my house. He knows about costs. He's got mental spreadsheets about how much things cost and should cost, and how much, if something costs more than that or less than that, is that a good deal or a bad deal? He knows all that stuff. But it's all woven together. You have different kinds of knowledge, different kinds of expectations. And so I call that a welter of knowledge. So a mental model is a set of expectations, a set of pieces of knowledge from multiple perspectives about a single task or system. So you might know a lot about how, say, Waymo works. You probably don't have a detailed model of how it actually operates internally, but you have a set of expectations about what normal behavior is. These things can be inconsistent or incomplete, and they will change over time, partly because the system changes, the world changes, but also your knowledge changes over time. So another study was done by a colleague of mine, was looking for how many different concepts of search, central concepts people had. And you can see on the far left, everybody knows what a query is, but on the far right, nobody knows what a user need is. They don't know what content linkage is. Example. I ran a study a few years ago where we had a bunch of people come in, and the screener, that is the piece of questionnaire you had to fill in order to get accepted into the study, said, I use search more than 5 times a week. That was one of the criteria. Woman comes in, and we're asking her about search, and it's very clear she doesn't search at all. She has never typed anything into a Google search box. We're trying to understand what happened. And when she said, in response to my question about the questionnaire, remember that questionnaire about 5 times a week? Yeah, she said, yeah, I do search more than 5 times a week. How do you search more than 5 times a week? Show me. And she starts clicking on links. She never entered a piece of text into a query field. For her, searching was clicking on blue links until she got to her destination. Right? I hadn't thought of that. But people have sometimes very, very different notions of different concepts about what it is you're doing. This is another version of the same study. People understand queries. They don't understand, for example, how to search in results, even though that's a trivial thing to do. People would constantly complain to me at Google, I did a query and I wanted to search within the results. How do I do that? Like, you add a word to the query and it will automatically search within the results. Nobody understood that. So something we thought was trivial and obvious turned out to be completely unknowable. Nobody's mental model had that. In Anthropology 101, one of the things you'll learn about are things called cargo cults. And a cargo cult were these little quasi-religious practices that sprang up in the islands of New Guinea at the end of World War II. And the interesting thing about cargo cults is that they were a religious response to all these guys from the United States coming to these little islands and setting up bases. They would set up an air base, and they would bring in machine guns and planes and tanks of fuel, all this stuff. And the locals thought, wow, that's pretty great. These guys come out of the sky and they leave stuff that they called cargo. And so a cult sprang up in response to this because at the end of the war, they all left. So the religious response was, how can we get those things to come back? So a cargo cult is this quasi-religious practice of, for example, making on the left-hand side there statues of white guys in uniforms, trying to attract them to come back. And people wearing what are models of airplanes because they'd seen the airplanes, they knew what they looked like, or building on the far right-hand side radio towers. So they're trying to do all the behaviors that they saw associated with cargo. Why am I telling you this? Because you see cargo cult behavior all the time. We see cargo cult behavior in you. For instance, have you ever, and I won't judge you if you say yes, but have you ever, for example, done a search, asked ChatGPT for a piece of code, a line of code, a script that you then copy pasted and ran without knowing how it worked? Yeah. The rest of you are lying. We've all done this. That's cargo cult behavior because you don't understand the mechanism. You don't understand how it's working. I've done this with awk and sed scripts. I don't want to learn awk. I don't have no interest, just copy paste it. It will just do the right thing. And 99% of the time it does. But I have no functional mental model of that. So I was interviewing this guy. He was about 20 years old, and was interviewing in his bedroom. And one of the things I said, so what can you search for on Google? Trying to elicit his mental model of Google search. He says, oh, I don't know, I can ask anything. I don't know how it works. I just type words and answers come back to me. Anything at all. He's completely convinced of this. Now you know and I know it's not true. It's really not true. But he's convinced that the entire universe of information is available to him. I found that interesting. Cargo cult behavior. So when we start thinking about building up a mental model of the things that we're trying to use, we think about, for search questions, you think about how is content indexed, how does Google look it up, how does it work, right? And is it predictable? What's so interesting is that people completely believe that doing the same query on multiple days will give them the same results. And that's really, really, really not true, right? I don't know about you, but I've had things where I saw a paper and I looked it up once and it's great, I got it, and I forgot to copy it and I can't find it again, right? So the underlying data set changes, and so predictability is hard. So people ask in their mental model, what's in Google? And how can I use it? How can I ask that question? So here's a couple of slides, probably too many slides, but bear with me for a minute. Trying to represent what the mental model is of people using this AI tool called Google Search. And there's a bunch of things people know about how the engine works. They know about how to choose good search terms, how to use special operators, all that jazz. They also know about things like information mapping. So this is part of their knowledge, part of their mental model about information search is that they know about things like keyword frequencies or reverse dictionaries, or that Wikipedia is a pretty interesting resource. They know stuff like that. They may not be able to tell it to you, but they understand about that. Then there's specific domain knowledge, like about plumbing or medicine or whatever it is. And then there's strategic uses of search behaviors. Right? And finally, there's the assessment and site-specific knowledge. So these are all 6 different aspects of the mental model. This is all what goes into the welter. Right? So this is a big study I did. And when you ask people, how are you going to search for something? For example, suppose you want to find what planets are visible in the night sky. I've seen people search for constellation. That's a terrible search term. You're not going to find the planets that way. Or searching for Red Hat versus Red Hat Society. Red Hat, the Unix distro, versus Red Hat Society, the older women's social group. One word makes a huge difference. So these all express different kinds of strategies. one of the things we see in people using these systems is that their use is often a multi-step process. So they will often navigate to a location, a site. They'll then ask questions in that site. And so if I ask you the question, which actor won the most Oscars in the course of the Academy Awards? It often is a multi-step process to figure that out. So people will go to a site and then, and just go on, do all that stuff. They will often then teleport to a particular site. And these are all behaviors that people have until they all fail and they try something else. And when they get stuck, people don't know what to do. When your AI system fails, what do your users do? What should they do? What's the escape hatch for people who are really stuck? Plan for that, because it will happen. So a kind of classic problem we see a lot in search is that people have things that they want to ask about and they don't know what to call it. So people, I don't have it on my shoe, but shoelaces and that little thing on the end of the shoelace? Anybody know what that's called? Do you know what it's called? Aglet. Does anybody know the word aglet? Oh, wow, I'm smart kids. This is great. Most of the world has no idea what an aglet is, right? But how do you find out? So you could search for it, and often you have difficulty finding the right terms for it. So here, for example, somebody comes in and says, I want to know what the foremost studding sail is on a ship. Like, I'm sorry, what? How do you find that out? A strategy, part of the mental model people should have of Google is that there's a wealth of diagrams out there that have labeled parts. And so a really great strategy here is to search for images with all the parts labeled and then look for the part you're looking for. And so that's how you find out that that's what that's called. Or if you've got a piece of software, what are those little applets, widgets on the bottom right? I have no idea what they're called. What's that? What's that? Are those tabs? Are the index points, or what are they called? We have all these things in the UI. How do we find out about them? Are they all the same? Do they all function the same? Not quite. So there's this concept called Norman doors. Don Norman introduced this idea of doors. Well, I'm just going to show the video here. Wait. After Don Norman, you probably know some of his writing. So a Norman door is something where the affordance is not signaled by the device itself. So people end up having to put labels on these things that say push or pull or whatever. And it cracks me up when I see people, you see people all over Stanford, doors that say push and people pull on them, or the opposite. And it works sometimes, not all the time. Or the other thing that drives me crazy is a double set of doors like this. I don't know if this is true for these doors, but often they'll lock one door, one side, and you go, right, smack your nose into the thing. That's a Norman door. When the affordance is not clear to the user. And so their mental model says, I should push on that bar, right? What's your mental model of what these AI systems can do? We've got Alexa, we've got these various agents we can talk to. What can you ask? So here's an example. I'm trying to get you to think about expectation setting to help people develop their mental models, okay? So which of these, I'm gonna ask you again, which of these do you prefer and why? The one on the left, which says try simple spoken commands like stop and go and so on, versus the one on the right, which says I'm your personal virtual trainer. People voting for left. Voting for left, okay? like 4 or 5, maybe. Okay. People on the right. Oops, you weren't supposed to see that. People on the right. People want. No, forget it. Blew it now. Okay. But the point was, the one on the right has great marketing. It tells you how wonderful your life is going to be once you start using this thing. But I would prefer the one on the left because it sets the expectation. That is, it guides your mental model to something that's useful, predictable, and easy to understand. Okay. So what we want to do as designers of our AI systems is to set expectations properly. So I've complained to you about this before. So this is Google Slides. If you want to animate some text, how do you do that? But you might go over to the search box and say animate, and it will not help you at all. So the expectation here is that there's no animation in Google Slides. And I know that's not true, but there's no affordance for that. It's a Norman door built into the UI. So I don't want to transition. I want to move something around on the screen. So what you have to do is, if you're lucky, you'll notice in the far right-hand corner there's an animate tab. But if the window's too small, it goes away. So it's invisible to you. A non-visible UI element has no affordance. So it doesn't help your mental model for this. So the thing you have to know, I'm helping you with your mental model of Google Slides, is it's called motion. Motion, of course. Then the other thing to notice here is, look at all those other things. I search for motion and I'm getting line decoration. That makes no sense whatsoever. Why do I have line decoration like round joint or miter joint or bevel joint? What? This is not helpful for developing a useful mental model. Don't add distractions. Add things that help people understand the model. So here we go. What do you think about the capability? Once you get to it, you can actually then add slide transitions. You can add all the animations. So what do you think? What's your mental model of search within Google Slides? Is it all just tokens all the way down? What it doesn't do, and what I think is a great product idea, would be to search over the contents of a menu. The menus are right there. It's just a data structure. You could search over the content of the strings in that menu, but they don't. They have a separate team that does the menu search. Okay, why am I going on and on about this? Because we have AI systems that can help us out. So my bike, this is the wheel of my bike. And here's an interesting gadget. This thing right here. How many people know what that's called? Okay. Wow. Everybody else? Giving the left side a chance here. What's it called? Okay. Well, it's a valve. What specifically is it called? Specific kind of valve? It's a, okay. This is a perfect teachable moment, right? Here's what you do. It actually was, just so you know, it was patented in 1897 as a improvement for inflating pneumatic tires. So this is an old device. It has literally been around for more than 100 years, and yet nobody knows what it's called. However, I can go to take that photo, drop it into my favorite AI system, and say, what am I looking at? That's literally the question. What am I looking at? And it gives me this very nice description, which says, oh, that's a Presta valve, also called a Sclavirand or French valve, and does all this stuff. And it describes the nut and how to use it. Beautiful answer. It solves the problem for me of what's this thing called. This is new, right? This was not a thing 5 years ago, 4 years ago, right? So what you can do now, actually, so that was what I intended. But suppose my intent was slightly different. And I rephrase my question and say, that's actually not what I was interested in. What I was interested in, and the query here is, I'm curious about the big curved thing that runs from left to right and is gray or silvery. What's that? Right? And it gives actually, again, I redirected the attention. Mental model time. You can reframe the question and refocus attention of the AI system to a different part of the image, right? So this modification thing is a basic step in all AI use. When we get to the Gen AI part for image generation, we'll talk about this in more detail. But the ability to move the focus of attention or the kind of solution that's being generated is key. So I'm telling you all this because when we design AI systems, we want to have the affordances to be clearly signified by the design elements. A signifier is the visual or perceptual cues that tell us what the heck this thing is. So in the wheel, the valve is its own signifier. It stands for, right? Or a symbol, if you want to get into semiotics, how do you know what a symbol is for a particular kind of thing? There's a little red light on your phone. What does that mean? That's a signifier for recording or whatever the interpretation is. So signifiers are these communication tools we design in order to help people understand what affordances are there. So in short, an affordance is the thing you can do with it. A flat plate on a door or a push bar like that one right there affords pushing, whereas a bar handle affords pulling or pushing. More frequently, it signifies pulling. As we develop more and more AI systems, we're starting to see more and more affordances come into play. And along with that, we're seeing the evolution of standards of kind of, in fact, de facto ways of representing these things, these affordances and signifiers. So here, for example, you might be able to use your favorite AI system to sketch a little thing like this. So I sketched the thing on the left using my favorite paint tool, and I gave it to a Gen AI system and said, hey, generate some variations on this theme. So what are the affordances on the AI sketch tool? Well, you can sketch whatever you like according to what the sketch tool allows you to do. But how much control do you have over the thing that's produced? Right? That's what the assignment number 2 is all about. How much control do you have? If it generates something that's not quite right, how do you fix it? What can you say? So in this particular UI, there are things you can change for the height and width and the scale to show you how much of the image will be like your original, how many steps you want it to iterate, how much to sample, what the sampling strategy should be. There's a bunch of stuff here, including the choice of model. So here I've chosen Stable Diffusion version 1.5. How is that better or different than the Stable Diffusion 2.4? I don't know. How would you find out? So as we move forward in building more and more sophisticated AI systems, what we have are interesting possibilities. So I'm going to show you this little clip of a video. This is a system called Duplex by Google. And it's a voice AI system. But what it does that's different is that in this case, Duplex calls a restaurant and has the following conversation. So listen to it. And the first voice you'll hear will be, the second voice you hear will be the AI system. This is the AI. Human. I love this demo for a lot of reasons, one of which is, this is 2018. In 2019, Duplex was supposed to be released to the world. And Google decided they're not going to do that because they use it to call businesses and ask when they're open. So, you know, when you use Google Maps, you go to Google, it says, oh, this place is open from 10 to 3, blah, 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 all that stuff. That's how they get that information, because shop owners hate going onto the web and updating their data. So what they built was this Duplex system to actually call the shops or the companies and ask that information. And it makes roughly 1 million phone calls a month. That's how all that data gets into Google. They ask. Now, when they first introduced this, the second reason I think I like this is it has all these funny little back and forth things, like, where is it here? Oops, back up. I'm gonna play this part. That's awesome. That's not a linguistic utterance. It's a paralinguistic sign of agreement. I'm listening to you, right? Let me tell you, there's no script for this. The way this works is, in general, there's a kind of a template of data that the system needs to get from the person, and they can do it in any order or whatever. There's a conversational UI element, which we'll talk about in a couple of weeks. We'll talk about the details of that. But it goes back and forth and has this very natural thing. When this was first introduced, it didn't say that it was a bot calling you. It now says, hi, I'm Gemini, the Google bot. I want to find out when the hours are, blah, 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 the rest of the conversation. So it identifies itself, because there was so much pushback from humanity. You said, what? I'm talking to a bot? That's what happened. So they add this prefix to all the conversations. You want to know what happened? People get a phone call from the Google bot, and they hear, hi, this is Gemini, the Google bot. And they completely ignore that. Interesting. Huge pushback. Make the change. Nobody notices. And nobody cares. So, but they had to do it. They had to do it for full disclosure, which I think is probably the right choice. So we're talking about affordances of UI systems and AI UIs. And we just talked about the linguistic model for Duplex. You've probably seen that your phone can now do all kinds of fancy in-image editing. So you can erase things. So for example, I've erased the orange cones on the right for this scene. Straightforward. Think about this. Think about this. You should be asking yourself, for every AI thing we introduce, what could possibly go wrong at the 3 levels, which are individual, application, and society, right? What could possibly go wrong? So here, I got something on my screen, and I think, oh, that's my son. I want to pick out that picture. So what can I do? Well, the iPhone's got this great object selection thing. So I can long press on my kid, and it copies out the image there, right? And now I can copy paste that anywhere. Question for you: what's the affordance? More importantly, how did you learn how to do it? I will tell you the answer to that question. The way people mostly learn how to do stuff like that, like object select an image, is they saw somebody else do it, or they saw an advertisement. So I saw Tobias do this image selection thing. How'd you do that? Boom. Oh, got it. Okay. I didn't have to write a script to do it, but I could easily use the UI, that kind of thing. So in this case, I can copy paste that image anywhere. Great. Now, what about selecting the guy on the left? So I go, wow, that's great. I can do that. I click on it, and I get text select. My mental model is what? I'm selecting objects that I perceive in the image. Why did I get this text select option? Any idea? Guesses? I had to play around with it for a while to figure it out. Why did I get text select? Answer: I selected text. So I happened to press on his number on his jersey. And the image reco said, oh, you're clicking on text. I'll give you the text pop-up, not the image select pop-up. I have to press somewhere else on his body without text. Okay. So the mental model I have is be careful what you select because it's going to determine the next possible action. So I ended up being able to figure that one out. Now, you should be thinking, like I said, what could possibly go wrong? So with modern LLMs, with modern Gen AI systems, you can say, here's a picture, my wife and I, some Pacific island. I want to remove that woman on the left, right? And it does actually a decent job. Okay. Why do you care? Hey, it's a very cool thing, right? Very cool. Very, very nice. It made up my arm, but whatever. Here's the problem. You can induce false memories very, very easily. So a false memory is a memory that you are completely convinced is yours and yours alone and genuine. So for example, a person looks back on a memory, something experienced, you would delete that person. That picture is now up on your wall at home or on your computer. Your memory changes to accommodate what you see all the time. Or another version of this, you take a picture of a crime in progress and the AI system edits out violence from the image. So when you go back to look at the image later, there's no crime. Your memory will drift to accommodate with what it sees. This is a profound effect, and there's a very nice paper on this. So, dang it, we're going to start next time with this, because I want you to think about what could possibly go wrong with this AI tool. You've probably seen it. You know how your phone will say, on this date, 10 years ago, you were, or 5 years ago, you were whatever. It shows you all those images. Think about this for next week. What could possibly go wrong? Okay, so we've got all these different affordances, and I'm going to close with this. I want you to think about how much does it matter for all this stuff? The mental models, the user models, all this stuff really matters because the way people think about it influences the way they use it, their buying purchase behavior, and the way things go wrong, like inducing false memories. So I want you to understand these things. That's why I hope you're here in the class. So here's our question for today. Got a couple minutes there. And while you're over the weekend, you're idling away, watching the rain come down, think about ways in which that auto memory feature could go wrong. And we'll start with that on Tuesday. Okay. And so while you're doing that, quick reminder for people on the wait list, I'm working hard to try to get you off the wait list. I think we've got capacity for everybody. We'll see. If you're not on by Wednesday of next week, come bug me again, drop me email, we'll get it fixed up. If you haven't turned in assignment 1, email me today, let me know. Turn in assignment 2 when it's due, I think in a week or 2, and have fun with it. It's totally a fun assignment. Okay, everybody got it? Okay, one more. Any other questions or thoughts? All this, I've sort of thrown a lot of stuff out there for you to think about. Oh yes, a couple of people have asked about office hours. There are no office hours today because I have to leave right at noon. But if you want to chat for 15 minutes, happy to do that. In general, office hours are right after class or by appointment. And of course, these two gentlemen are available for you to make an appointment with anytime. Right? Contact them using the methods described in the syllabus. All right. Thank you very much. See you on Tuesday. Did you just end yours?
Welcome. I did indeed.
Okay, great.
It'll keep running for a little